Hello students, I am Dr. Gajendra Purohit and today I am going to start a new topic which is Discrete Mathematics. For quite some time students have been requesting me to upload videos on Discrete Mathematics. And so I am beginning from today. Today I am going to give you an overview of Discrete Mathematics. What does Discrete Mathematics mean? So first of all there are two things. There is continuous and there is discrete, right? Continuous means where there is a continuous sequence, meaning there is no gap in between. Let's say when I consider an interval here. From 1 to 2, this is the interval. This means that in this interval from 1 to 2, every point is covered, right? So this is continuous. But if I tell you that within 1 to 2, the points we have are coming between 1, 1 by 2 and 2 and there is no other point. Meaning this set is 1, 1 by 2 and 2. Except these, there are no other points. It will become discrete. Points in between are not included. So here in this subject, discrete means not connected. You see it's not connected. But here every element is connected, right? Between 1 and 2, every element will come here. This means
1.001 will also come. 1.002 will also come. Every point will come, right? Every point present between 1 and 2 on the real line, all will come, right? But students, when we talk about discrete, let's assume we have this set.
And in it 1, 1 by 2 and 2 is present and there are no elements in between. So it is not connected, meaning we call it disconnected, right? Let's take an example.
Natural numbers are discrete because it includes 1, 2 and so on. The set of integers is discrete because 1 is coming, 2 is coming, minus 1 is coming, but the elements in between are missing. Clear?
Similarly, when we talk about rational numbers,
it's also disconnected because there are no irrational numbers in it, right? Students, what is discrete mathematics? Discrete mathematics is a subject of objects and these objects can be of any type, right? It could be letters like A, E, I, O, U, or it could be elements of any size, numbers of any size,
or something else, right?
So ultimately, students, when we talk about discrete mathematics, here we will also talk about finite sets. Now, what are the advantages of discrete mathematics?
Or why do we study this subject? Students, this enhances your mathematical thinking and develops it. If you want to make a career in computer science, then this is a very important subject. It will be very useful in coding and many other subjects that we study with computer science. It has also application in it, right? Students who are going to college also have it in their syllabus.
If you are doing engineering, if you are doing B.Sc, or if you are doing any other course like BCA, MCA in that,
the entire course of discrete mathematics is there. And there are many math problems that we can solve with the help of discrete mathematics, right? Now let's move forward.
Here, when we talk about examples, we consider what type of problems we can solve. For example, finding the shortest path between two objects or drawing graphs with conditions, right? When we study graph theory, there will be many things used there. The logical thinking we study, the logic we study is also a part of discrete mathematics. Let's take a look. The syllabus which I am going to cover in this entire course.
I will cover it in lecture by lecture. And the special thing about my YouTube channel is that I continue with topics. Now as I have started discrete mathematics, I will cover the entire syllabus of discrete mathematics. What all I will cover? Let's see. Sets, functions and relations. In this,
the pigeonhole principle will also be covered. After that, we will cover hash diagrams, lattice
combinatorics,
propositional logic, finite state machines, recurrence relations, and generating functions, and graph theory. I'm going to cover all these topics in this series.
Let's begin.
So students, let's talk about sets. Sets have a very simple definition that we study in the 11th class. Also, I have uploaded a video on it on my YouTube channel, which you can access by clicking on the I symbol. Students, what is a set?
A set is a collection of well-defined objects. For example, if I ask you what vowels are present in the alphabet, you know what they are. If I tell you from what will be the even numbers between 1 to 100, what will be the odd numbers, what will be their set, what will be the prime numbers, what will be the numbers divisible by 3, so these are all well-defined objects. So what do we have as a collection? What is it? It is a set. But if I ask you what is the scariest creature for you? If I ask you what will be its set? So for every person there is a different scary creature. Some people are afraid of cockroaches, some are afraid of lions, some are afraid of goats, right? In that case it will be very different for everyone. So there won't be a well-defined object for us. And so that collection will not be a set, right? If I ask you what your best book is, it will be different for everyone because everyone has their own best book. Someone may like a certain genre of books and someone else may like another genre of books. So we won't have a well-defined object there and we will not have a set for that collection. Now if we have a set, firstly let's talk about the types of sets. First let's talk about the empty set. So what is an empty set? A set having no elements is called an empty set. It means a set in which we don't have any elements. So what do we have? It becomes an empty set. If I ask you between 10 and 100, which is both an even number and a prime number. So what will the set become for us? It will become an empty set. Clear? You need to keep this in mind. Clear? So what is an empty set? So the meaning of an empty set is where nothing exists, right? Singleton set. A set having only one element is called a singleton set. If I ask you which number is an even number and a prime number between 1 and 100, so the answer would be 2, which is both an even number and even a prime number as well. So that set will become a singleton set. Now let's talk about subsets. What is a subset? A set is called a subset of set B if X belongs implies X belongs to B. It is expressed as A is a subset of B. So what happens here? A big set has a subset, a small set. For example, if I tell you we have a set containing 1, 2, 3, 4, 5, 6. Now if I ask you to take any subset of this which has odd numbers, what will be the set of odd numbers for us? It will include 1, 3, 5. Here set B contains in set A. It's taking everything that set A has, right? So B will become a subset of A. That's how it can be understood. Suppose set B has AEIOU and set A has AEI. So set A contains in set B. Getting my point? So A is a subset of B. Now what is the meaning of the power set? That any set given to us, right? The family of all subsets of set A is called the power set of A, right? So what is a power set? For example, suppose we have any given set. Let me take a set X for you, which has elements 1, 2 and 3. What all subsets can we have in this set? So first we will have an empty set where no element exists, right? Secondly, we will have one where only one element exists. The second one will have only one element 2. The third one will have only one element 3. Students 1, 2 and 3, all of them are the subsets. It can be 1, 3 or we can consider 1, 2. So possible combinations are 1, 2 and 1, 3 or 2, 3. Or we can get the whole 1, 2, 3. Right, so here we have the subsets of 1, 2, 3, 4, 5, 6, 7 and 8. So in total we can get 8 subsets. Now students, for all the sets we have, if we take their collection, like if I am a collection here, I'll take the collection which includes 5. Then I'll take 1, then I'll take 2, then I'll take 3, right? Then them. Take their collection. Then this will come 1, 2, 3. So whatever subsets we have, we've taken the collection of all of them. So what do we call this set that we have here? It's called the power set of X, meaning the collection of all the subsets we have. What is that called? It's called the power set. Now, how many elements will be in the power set? That whatever elements we have, there are 3, right? Take the power of 2 to 3. So we'll get 8 elements. Look, if you count 1, 2, 3, 4, 5, 6, 7 and 8. So in this way, we can define the power set. The collection of all subsets of a particular set is known as a power set. Getting my point? Moving forward, students, there are some concepts and fundamental operations. Whenever we talk about sets, like normally if there are 2 numbers, then there is addition, multiplication, division, subtraction, right? So we know about this. So here there is no addition, subtraction, division. Here there is union, intersection, Cartesian product and difference, right? Now how does this happen? I will explain it to you. We will discuss about it. But I will give you a quick idea about it because questions come in the exam. Suppose we have a set A given as 1, 2, 3, 4, 5 and set B is given as 3, 4 and 6. Let's say we have sets A and B. If you were to find their intersection, or let's first talk about their union. So the union means how many totals do we have when we combine both? How many do we have after combining them? 1, 2, 3, 4, 5 and 6 will become the new set, right? By simply combining them. You don't have to repeat the elements. If 3 comes twice, write it only once, not twice. So what will we get in this case? It will be the union. What does union mean? It means an element such that X belongs to A or X belongs to B. Our element should either be in A or in B. Since they are common in both, we will write it only once. Clear? Now let's talk about intersection. So the intersection means the common elements in both. So students, what are the common elements? 3 and 4. So this will result in the intersection, right? X such that X belongs to A and X belongs to B. So students, X should either be in a A group or in a B. It should be in both, right? Or is coming in between. So here 3 and 4 will come. Now we will talk about the difference, A minus B. So students, remove the elements of B from A. So which elements are in B? 3 and 4, remove them. So what will be left with us? 1, 2 and 5. So what we will have? It will be A minus B, x such that x belongs to A and x does not belongs to B. So remove all the elements that belong to B from A. What will we have? The difference will come, right? And this will be with us. Now let's talk about the Cartesian product, students. How do we find the cross product of two sets? So what is the method to find the Cartesian product? Multiply these two, 1, 2, 3, 4, 5. How do we multiply, students? You don't need to misunderstand my words. Understand what I am trying to say here. How do we find its Cartesian product? The first element will go first, so this will come 1, 3, right? First will be 1, 3, then will come 1, 4, then will come 1, 6, then we have 2, right? What's here? 2, 3, 2, 4, 2, 6. Then 3, 3, 3, 4, 3, 6. This will come. Again we will have 4, 3, 4, 3, 4, 4, 4, 6 will come. We will talk about 5 in the same way, right? 5, 3, 5, 4 and 5, 6 will come. This is called a Cartesian product.
Like we have given two sets here, we have to find the Cartesian product of these two. So what we will do, students? So first element of A will go with first element of B. We get 1, 3. Then first element of A and second element of B and so on. So we get 1, 3, 1, 4, then 2, 3 and 2, 4. This is how we write it, and this is known as the Cartesian product of two sets.
Now let's look at the questions that have come in the exam. These are all the questions that have come in exams. Sometimes we are asked to prove something. A is given to us, B is given to us, C is given to us, and you are asked to find its value. A cross B intersection A cross C. So students, we have given A, B given. First, let's find the value of A cross B. It will be 1, 4. It will go first. Then we will have 1, 5. The first one will go to the second. Then we will have 4, 4 and 4, 5. This will come to us. A cross B. Now let's talk about A cross C here. So students, what do we get when we have A cross C? We will have 1, 5, 1, 7. Look, this will be 1, 5 and 1, 7 will come, right? And next we will have 4, 5 and 4, 7. Now the question is about intersection. What has been asked here? A cross B intersection, A cross C is being asked. What is being asked to you here, students? A cross C is being asked. Clear? This will come to us, A cross C. So what is the common element between these two? We have 1, 5, coming in common. So this will come to us 1, 5. 1 is coming to us here, but 1, 7 is not coming in common. 4, 5, right, is coming to us here. So this is what we will get and not the others. So this will be considered as the intersection. Let's take some more questions that are often asked in the exam. Sometimes questions of proof are often asked in exams.
Students get confused with such questions and often ask me about the basic understanding of solving such questions.
Look at the question. Let ABC be any three sets, then prove that this will be equal to this, right? So firstly, we take an element. Let us assume that x, y belongs to A cross B intersection C. It means this element we are taking here, clear? The meaning of this is that the first part will be x belongs to A and y belongs to B intersection C. Now look here, x belongs to A and both are going to intersections. This means that y belongs B and y belongs C. Understood? Now we have to prove that this will be equal to this. So students, I can write it as x belongs A and y belongs B, right? And I can also write it as x belongs A and y belongs B. And I can even write x belongs to A and y belongs to C. I can write it as this also. So we will do like this. Ultimately, what we have to do here is, suppose I am writing this one like this and this one in this way. Clear? What does this part right here mean? X, y is going to A cross B, right? Now students, x, y will go to A cross C. Now x, y is going in both A cross B and A cross C. This means that x comma y belongs to their intersection also, right? So it will be a cross B intersection A cross C, right? This means that we took an element from here and put it here. This means this will contain in this element. That simply means that A cross B intersection C will contain in A cross B intersection A cross C. This contains this thing. Now we will take an element from here and show it in this part. So if this part will be contained in other part, then both will be the same, right? And we are going to do the same. Next, let me change the color. I'll take it in from here. What did I bring along, students? I brought along x comma y belongs to A cross B. And it will be an intersection here. Sorry, we have to write intersection here. The intersection will come here. This will come to us as an intersection. This will come as A cross C. Now what happens here? The first element is coming from the first place and the second element is coming from the second. This means that x comma y is going into both and into this intersection. This means that x comma y belongs to A cross B and x comma y will also belong to A cross C. In both cases, it belongs in both. This means that when it belongs to both, it means that x belongs to A and y belongs to B. It's a Cartesian product. So we can write it like this. And what will come here, students? So x belongs to A and y belongs to C, as you can see here. Now you see here x is also coming in A and here also x is coming in A. Similarly, y is coming in B as well as, and what do we have for y? It's also in C. So what we will do here, you see we have x here in both, right? So I can write this, that x belongs to A and what do we have here? Y belongs to B and y belongs to C, right? This means y is coming in the intersection of both. So I can say that y belongs to B intersection C. So we are considering that x belongs to A, which means x comma y will be in A cross B intersection C. So we took one element from here and brought it in, meaning A cross B intersection C that's coming. A cross B intersection A cross C is being contained in A cross B intersection C. So what did we do first? We contained this as a part of this. Now we have contained this as a part of this. What does it mean? That they both will be equal, right? And this is what I have tried to prove here. If you understand this proof, then you can clearly see that I have tried to prove that the same thing here. And you can understand from this example, right? Students, let's take the next question. In this too, we are going to do the same thing. Look, students, pay attention. What does the next question say? It says that ABCD are any four sets. Then prove that this is equal to this. We took x comma y belongs to A intersection B cross C intersection D. Clear? Now, students, it is necessary to pay attention here. If this is cross, then the first element will go first and the second element will go to the second. This means that x belongs to A intersection B and y belongs to C intersection D. Tell me, is it clear or not? You need to keep this in mind. This will go into the intersection. Now, since it's going into the intersection of both, this means x will also go into A and also into B, right? Tell me, is it clear whether you understood or not? It's going into the intersection. And what will come here? Y will also go into C and also into D, right? This is necessary for you to understand. If you understand this, then the question will be understood quickly. Is it clear? Now we are seeing that x is also going into A, and what is happening here? When you see here what's happening, if you take it, then what's happening here? X is going into A and y is going into C. So I can write this as x comma y is going into A cross C. If we write it like this, right? Here you see x which is going into B, and what do we have for y here? It's going into B, so we can write it like this. X comma y will go into B cross D, right? We can write it like this. So you see x comma y is also going into this and it will go into both, which means it will go into the intersection of both. So x comma y will belong to A into C intersection B into D. And that's what we were supposed to prove here. So in this way, we can easily prove it. Now, you took one element here and brought it inside. This means that A intersection B into C intersection D is containing A into C intersection B into D. Now let's do the reverse. What we will do now I'll take that one element is in it and I'll contain it here too, right? So it will be contained inside the reverse. So that's what we are going to do. Let's take x comma y belonging to A cross intersection B cross D If x comma y is in the intersection of both, it means it will be separate in both. This means that x comma y will belong to A cross C and x comma y will belong to B cross D, right? Because it will go in the intersection of both. This means that x is going in A and y is going in C.
Sorry, the first one will be the first element. What happens in the Cartesian product? The first one belongs to the first one and the second one belongs to the second one. And what will happen here?
And x belongs to B and y belongs to D. Clear? Now you see here x is also going in A, x is also going in B. This clearly means that x will go in its intersection, am I correct? Y is going in C and y is also going in D. So students, what will come here? Y will go in the intersection of both. Now x and y will go in the Cartesian product of both x and y. So the first one from the list. So what will come here for the first one belongs to A intersection B into C intersection D. So we have proven here that we took one element from here and it came in this. And this contains this. What does this mean? If I imply it, then it will result in A cross C intersection B cross D and contains in this part, meaning it contains A intersection B cross C intersection D. If this contains inside this and this contains inside this, then what will happen of both of them? They will become equal. So we can prove it very easily in this way. I've explained the proof here as well in the solution. So let's take a look at the next question. It's a very good question. The question is stating that if A and B are any two sets, then prove that A intersection B minus A is equal to phi. So here also we are going to do the same thing. Students will take one element and proceed, right? So x belongs to A intersection B minus A. I'll take this. Now let me tell you, if x is in its intersection, then it means that x will also be in A and x will also be in B minus A. And whenever we have x in B minus A, then the element x will be somewhat like this. X belongs to A, which means that x will go into B. But x does not belong to A. Whenever this happens, whenever an element is going into B minus A, then x should be in B, but should not be in A. Because whenever we take the difference, what do we do in it? As I told you before, let's assume we have elements 1, 4 and 6 inside B. And we have an element 4 inside A. If I tell you to subtract A from B, then how will you solve it? You will remove 4. So remember 1 and 6 will come. So it means that whatever element we have in B should not be in A. Clear? So if in this difference we have an element, it means it must be in B, but should not be in A. So you need to understand this. Clear?
Now you see here x is going to A, but x does not belong to A.
X belongs to A and x does not belong to A. But it's not possible that x is going to A but not going to A. What will be the meaning of x then? It will go into the empty set. Because it doesn't exist here, there is no element like that. So how will this be reflected here? X belongs to the empty set and x belongs to B. Getting my point? If x is also going to phi and x is also going to B, it means it will go into the intersection, which means that x belongs to phi intersection B, and we know that if phi intersects with any set B, then it will become an empty. So this means that x will go into an empty set. And as there is nothing in the empty set, it will become empty. This means its value will be taken from here and placed here. Where will this part go? It will contain an empty set, and if it contains an empty set, it means it will become an empty set by itself. And that's how we can prove it very easily here, like this.
So students, thank you so much. Please do let me know how you like this first lecture of Discrete Mathematics. Next, I'll be presenting concepts related to relations and functions. So stay tuned, students.